Welcome to Nutrition and Metabolism, everybody. First, we're going to look at some of our OG food guides, food pyramids, etc., etc. This bad boy right here on this first page, it originated in the 40s, so 1943, lasted until about 1956. And you can kind of see the groupings all of the foods we consume have been kind of sorted into. So this was during wartime rationing. They really wanted you to get everything into your diet, and in addition to those basic ones of fruits, vegetables, potatoes, milk products, meat, bread, flour, butter, margarine, you could basically eat anything else that you want. So this is one of the original. We know now that this is a little bit different in this day and age. So fast forward into 1956, and this one lasted for a really, really long time, 56 through 92, and it's essentially just make sure you get these basic four food groups into your daily diet. So meat, dairy, grains, fruit, and veg. Not inherently wrong, but it doesn't really provide you any information as to what do I do with this thing, right? So now we get into the 90s through 2005. So this did not last as long as the previous, but this one has been ingrained into my psyche. Every time I see this, I think, oh, elementary school, food pyramid, this is what we're learning. But this is what we had in the 90s and early 2000s. It's what I grew up with, and this was the standard for that time. This is actually the first food pyramid with the premise of what you should be eating most per day. And it kind of gives you all of the servings that you should have in that day. But what does a serving mean? 6 to 11, 3 to 5, 2 to 4, if you add all those up, that's a lot of servings throughout a day. So this wasn't, very intuitive in the grand scheme of things, depending on how big your personal serving size is. This was also known as the feed lot pyramid. So this pyramid was actually used to fatten up livestock at the same time. The idea was give them grains, cereals, pasta, and then a little bit more sparingly as we get to the very top. But that was used to fatten up livestock. Probably not the best to use for us. Moving on. Then we get to 2005 through 2011 with my pyramid. This one didn't really take. This one made even less sense than the previous ones. Not many folks loved it. Clearly a difficult read. Like, what does all of this mean? Okay, orange is grain, green is vegetable, red is fruit. Is this talking about proportions? What's this talking about? Why is this guy moving up the pyramid to eat less? Nobody really knew what was going on. So that kind of brought us to the current food pyramid. You probably don't see this a whole lot. We actually use a different My Plate sort of grouping, but this is technically the current food pyramid from 2011 to now. Notice the flip. So here, the top, we have the white rice, breads, potatoes, pastas, anything to use sparingly, including most of those grains that we saw in the pyramid that I grew up with. But kind of the fish, nuts, legumes, veggies, those kind of stayed in the same realm. But at the bottom, we've got plant oils and whole grains. So the grains kind of split up between, white rice, white breads, whole grains, etc. Choose My Plate is pretty much what's used the most right now. So divide your plate into fourths, easy to see, easy to read, easy to work on your diet visually like this. So protein, produce, to include fruits, when you say produce, and 2 bite carbs. So grains are also, remember, your starchy vegetables, so corns, chickpeas, dried beans, potatoes, white breads, white rices, sweets. Those are, or I'm sorry, white potatoes and sweet potatoes, the starchies, the starch veg. Those are also grains. So don't get those confused with vegetables, because then your proportions are going to be a little bit off. So this is the same thing, Harvard's Healthy Eating Plate. This just kind of tells you specifically what the breakdown is. So whole grains, like I was just saying, sweet potatoes and white potatoes are both included in that. Corns, dried beans, chickpeas, those are all included in that. Just like you can see on the vegetable side, the more veggies the better, but potatoes and french fries do not count as vegetables, technically. They are starches. So there aren't going to be a lot of pictures in this lecture, unfortunately, where we're talking about nutrition and metabolism. That's about the long and short of it. There'll be another picture a little bit later talking about amino acids, but just go with me here, follow along, listen to what we're looking for, what I'm looking for you to know here, because there's a lot of information and unfortunately not a whole lot of what we've been used to anatomically to talk about pathway wise. But anyway, one of the most important things when it comes to diet and control is your appetite. We have short-term regulators and we have long-term regulators. So know the differences between these with ghrelin, peptide YY, and CCK. But first, let's talk about 3 chemicals that act as short-term appetite regulators, and then we'll talk about just a couple as long-term regulators. So short-term take minutes to hours, long-term regulators can take weeks to years. And we also have neurotransmitter control, which is instantaneous. But first, short-term regulators and the chemicals within. So first, we're going to talk about ghrelin. You have also heard of ghrelin as the hunger hormone. So this chemical is secreted by parietal cells in your stomach when the stomach is empty. And these stop secreting 1 hour after eating. So if you eat slow, you're in a lot better shape to not overeat, because ghrelin will keep being secreted until an hour after you start eating. So that is why even if your stomach is getting full, you can still feel hungry afterwards, because ghrelin keeps getting pumped out. Now, if you're a really fast eater, ghrelin can make you pack in more food than what you'll need. Something to kind of help with that is drinking a glass of water before eating, because it can help trick your stomach, fill it up so that you don't pack as much in if you're a faster eater, and kind of like try and inhibit some of that appetite. Ghrelin, so hunger hormone, a lot of diet pills, a lot of the new lose weight fast shots that people are getting inhibit your hunger hormone, ghrelin. While you are taking these things, you will notice a lot of weight loss really, really quickly, because you are not feeling that hunger that you normally do feel, that appetite. But unfortunately, what people see a lot is once they are off of this medication, they experience that yo-yo effect, right? So you lost a lot of weight. And we'll talk about this a lot towards the end of this lecture in terms of what you're actually losing. Is it fat? Is it muscle? But anyway, you're off these appetite suppressants, and guess what? You're going to start feeling hungry again, and you're going to eat like you used to eat, and you're going to just pack those pounds back on. But anyways, that is a segue. Ghrelin's your hunger hormone. It's secreted by parietal cells in your stomach when your stomach is empty to tell you that you're hungry, and they don't stop secreting until an hour after eating. So remember that. Remember the difference between that, peptide YY, and CCK. So peptide YY is actually secreted by your intestinal cells as food enters your stomach. So don't get that confused, okay? Peptide YY, it is secreted by your intestinal cells, but it's as food enters your stomach, not your intestines, okay? Don't mess that one up. The intestinal cells get a signal from your nervous system that there is food coming to your stomach, and then the amount of peptide YY is directly proportional to the amount of calories that you are eating. So the more you eat, the more peptide YY you make, which in turn turns on your satiety reflex and tells you that you are full. Get a drink of water. Okay. And then we have CCK, or cholecystokinin, and that's secreted by intestinal cells also, but remember how we were talking about chyme and the duodenum getting hit by bile and pancreatic juice? So CCK stimulates those. As soon as you start eating, CCK is like, all right, well, we got to start making this bile and pancreatic juice to help with this chyme that's coming out of the stomach and into the small intestine. CCK also stimulates the vagus nerve to turn off your hunger. So know the difference between these short-term regulators of appetite. Now we have some long-term regulators. So these can take weeks to years. There are a lot of these, but we're going to talk about leptin and insulin. So first we're talking leptin. This is secreted by fat cells, directly proportional to the amount of body fat you have. So this stimulates norepinephrine, which stimulates lipolysis. Lipolysis. So the higher the body fat, the higher the leptin, which tells you to make more norepinephrine, which tells you to break down more fat. So lipolysis is fat breakdown. So lysis, breakdown, lipo, fat. Lipolysis, fat breakdown. And leptin stimulates that breakdown of fat. So that's a good thing, right? It's a good long-term regulator of appetite. Another is insulin. So insulin, I'm sure you guys have heard of, and we have talked about it before. It's secreted by beta cells in the pancreas. So stimulates glucose, stimulates amino acid uptake, it promotes glycogen and fat synthesis. So in other words, once you have too much glucose or too many amino acids, insulin tells your body to start storing that either as glycogen, or once all glycogen stores are full, store it as fat. So you have to watch how much starch you eat, because starch breaks down to glucose, and then how much glucose you do eat, because if you eat more glucose, sugar, starches, etc., 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 they all break down to glucose. If you eat more than your body can use at that time, it will be stored as glycogen, which is quick energy. But if all your glycogen spaces, think of them as spaces, are full, then those extra glucose are going to be stored as fat. So you got to watch that. And remember this, because we're going to talk about this a lot throughout this entire chapter. There's also neurotransmitter control. So norepinephrine stimulates for carbs. Ghrelin stimulates for fats. Endorphins, those stimulate for proteins. Know the difference. Know the difference. Don't be surprised if this pops up on the quiz, okay? So norepinephrine, carbs, ghrelin, fats, endorphins, proteins. When your body thinks you need carbs, for example, it's going to enlist norepinephrine's help to say, hey, you really want to eat that bread or that potato, you know? Calories, the oh so loved calorie. So many definitions here depending on what line of work you're in or what perspective you're taking. The chemistry definition of a calorie is the amount of heat that will raise the temperature of 1 gram of water by 1 degree Celsius. So to find out how many calories are in a food, scientists will burn it and see how much heat it takes to move the temperature of 1 gram of water up by 1 degree Celsius. That's the chemistry of it. I had to give you that definition. Then we have the capital C calorie. So that's 1,000 calories. And what we talk about a lot in dietetics and diet planning, dietitians talk about. And that's actually what we see on our food labels too. And then in biology, biochem, physiology, we call that kilocalorie, kcal, which is also just talking about 1,000 calories. On food labels, it's going to say lowercase cal, but it really means an uppercase cal here in America because 1 calorie is actually 1,000 calories. In other countries, if you look at food labels, it says kcal, so kilocalories, and that is a lot more accurate than what we see here. It's a little bit misleading. So really, if you're eating 10 calories, you're eating 10 kilocalories and 10,000 lowercase calories, right? So other countries got it better than we did here. Know this list right here, okay? Sources, calorie sources. So we got 4 kilocalories per gram of carbs and protein. We have 9 kilocalories per gram of fats. And we have 7.1 kilocalories per gram of alcohols and sugars. Or in, not really of. So sorry. Emergency weather alert. Apologies. Let's start that over. So 4,000 calories or 4 kilocalories per gram in carbs and proteins. 9,000 calories or 9 kilocalories per gram in fats. And 7.1 kilocalories per gram in alcohols and sugars. Alcohols and sugars, so there are no nutrients here, just empty calories. But remember this list. It will be on your exam. Okay, so carbs. Carbs have 2 sources. You can get them from your body itself or from food that you eat. So in the body, if you have too much glucose, your body stores it as glycogen, and 75% of that is stored directly in your muscles. So if you're running and you need an extra boost of energy, it is right there in your muscles. 20% gets stored in your liver, and 5% as blood glucose. Food. So in food, we have monosaccharides, disaccharides, polysaccharides, right? Saccharide, you see SACCH, just know it's talking about sugar. Mono 1, di 2, poly many, okay? So monosaccharides, single sugar, so these are pretty basic. Glucose, galactose, fructose, all of these break down from disaccharides and polysaccharides. Some common disaccharides that you're used to are sucrose, which is table sugar, lactose, which is milk sugar, and maltose. And then polysaccharides are starches and fiber. Effects of carbs on the nervous system. So think brain. So it gets almost 100% of its fuel from glucose. If you run out, you will notice some memory issues, some cognitive dysfunction, some issues with the nervous system where your nervous system just isn't working right because your brain gets pretty much 100% of its fuel from glucose. So this is a fun fact at a party or something. I remember somebody told me that the brain was made of fat, so they should eat more fat. And I was like, nah, it's not really how that works. So brain gets its fuel from glucose, from sugar. So you can whip that one out if you ever hear some nonsense. Anyway, and then there's blood sugar. So glucose circulates to your different organs via your blood as the transportation system. A couple terms that are associated with this are your glycemic index, and know that you guys have heard of this in your daily, life on the internet, TikTok, Instagram, glycemic index foods, etc., etc. News, if anybody watches that still. So the glycemic index is just a scale of different sugars or a scale of how different sugars affect blood glucose levels, right? So foods with high glycemic index, which we'll look at the end of this lecture, they break down and get in blood fast. That is not necessarily a good thing unless you're in a starvation scenario. In all other cases, foods with high glycemic index are not that great for you, right? Foods with low glycemic index are a lot better. They break down and get into blood slower, so they actually allow insulin to take care of that, steady flow. And then your recommended daily allowance of carbs is no more than 25%. So remember my plate, 25% of the plate should be about as much carbs as you're ingesting. Metabolism of carbs. I'm going to keep this as simple as possible. This is more bio class. We do a whole week over aerobic, anaerobic respiration, right? Cellular respiration, if you will. We're going to spend 2 slides on it. Okay, so this is going to be very, very fast, very, very basic. We're not going to get into the formulas. We're just going to talk results. So with carbohydrate metabolism, we break them down in steps to decrease energy waste as heat's given off, right? So if you burn carbs, you lose the energy. And how do you lose that energy? You lose it in heat. So we process these in pretty useful pathways. There are 3 of them. Glycolysis is the most simple. Then we have anaerobic respiration or fermentation, right? So the same way you make beer, right? No alcohol. And then aerobic respiration, which is going to be a little bit more complicated than the other 2. So with glycolysis, sugar, lysis splits or breaks down. So glycolysis, sugar is splitting into 2, we call them pyruvates, really basic forms. And the result is 2 ATP. ATP, adenosine triphosphate, that's your energy source, right? And that's all that we'll say. I'm not going to get into depth there. Anaerobic respiration. So here we have no oxygen. It changes pyruvate to lactate. So if you're breaking down pyruvate, lactic acid can be a byproduct. So you guys have heard of that in terms of muscle soreness. That gives a net of 2 ATPs. So again, you made a little bit of energy there. And then we've got aerobic respiration. So this is with oxygen. It changes pyruvate to carbon dioxide and water through, we call it the citric acid cycle or the Krebs cycle. It's both the same thing, just depends on what book you're looking at. And goes through the electron transport chain. Result, 32 ATP. So aerobic respiration gains you the most net ATP, net potential energy, if you will. So that's all that we'll say there. I'm not going to get into the depths of the citric acid cycle or Krebs cycle, whatever you want to call it. Electron transport chain could be its own presentation in and of itself, right? So just know the difference between these 3, 2, and 32. A net of 36 total ATP through carb metabolism. B vitamins, niacin, riboflavin, they provide coenzymes NAD and FAD for these processes. So without these coenzymes and B vitamins, this wouldn't happen. So niacin, riboflavin, they're both B vitamins. I should have added more punctuation there. If ATP is not used from glycolysis, it is stored as glycogen or fat. So like I said, we're gonna talk about glucose storage a lot. Know these will show up on your quiz. Glycogenesis, so genesis, to make, to create. Glycogenesis is the making of glycogen, right? That's stimulated by insulin. Glycogenolysis is glycogen breakdown. Remember, every time you see lysis, it's breakdown, it's splitting, it's cutting, right? So glycogenolysis is breaking down glycogen into glucose when there's no glucose available. And this is stimulated by glucagon and norepinephrine. And then we have gluconeogenesis. So break that down. Sugar, new, to create. So you're making new glucose from glycerols and amino acids after several weeks of fasting because you don't have any glucose. So your body has to make it. So glycogenesis, making glycogen, stimulated by insulin. Glycogenolysis, breaking down glycogen into glucose when there's no glucose available. And then gluconeogenesis, making new glucose from glycerols and amino acids. And this is, when your body's in starvation mode after weeks of fasting. We have talked about this in a previous chapter. This is just touching on it again for carbohydrate metabolism. Know the difference between these three. Fiber. So dietary fiber, it cannot be digested. Recommended daily is around 40 grams. And there are two types here. We've got two types of soluble. Water soluble and water insoluble. Two types of fiber. I'm so sorry. Water soluble fiber and water insoluble fiber. So with water soluble, pectin is what makes it water soluble. So you can find this in oats, beans, peas, carrots, brown rice, fruit. If you guys have ever soaked oats overnight, or have cooked beans, peas, or carrots in water, you'll notice that they thicken on their own. So what's causing that thickening on their own is called pectin. So water soluble fiber reduces blood cholesterol and LDL. And we'll talk about LDL. That's the not so great one. Water insoluble fiber, this is cellulose and lignin. So this is the roughage that you eat. This is good because it makes your food actually absorb the water, because your body isn't. It's insoluble. It's not soluble. So your body's not absorbing it. Rather, what happens is that the cellulose lignin, the roughage that you just ate, is absorbing water itself, which creates a greater mass for a bowel movement. So that's going to create a mass. That's going to cause the stretch reflex in your intestines and peristalsis to create those wave motions to, give you a bowel movement and into the toilet. Lipids. We also call these fats and oils. Lipids transport fat-soluble vitamins in the gut. You want in your diet less than 20 grams a day. I'm sorry, you don't want less than 20 grams per day of fat-soluble vitamins, of lipids, because that can actually lead to vitamin deficiency. So you remember all of those fat-free diet fads? There was a reason that they were just fads, because they were actually causing a lot of problems later, which we will talk about if you don't have enough fat in your daily diet. Now we have diets like keto, which are fat-only diets. They're also not that great, which we'll talk about. But the trick here is to be somewhere in the middle, right? So learn to choose good fats to ensure that you're getting the correct daily vitamins you need for functioning. And yes, you can get those from fats too. Lipids are also in our plasma membrane. So remember the phospholipid bilayer from intro classes or Anatomy 1 or Intro Bio. So they are in our cells, right? Cholesterols They are an ingredient of steroid hormones. Bile, vitamin D, all of these you need, right? So you need lipids. Blood clotting factor, you would not be able to clot your blood without lipids. Lipoprotein thromboplastin is what that's called. Blood clotting factor. Arachidonic acid, ARA, and linoleic acid, fatty acids. These are used in making prostaglandins and eicosanoids for inflammation, fever, blood pressure. And then we have fat. So body fat, adipose tissue, it is used as an insulator against heat loss. Fat's also used as a cushion for your bones, etc., etc. So, lipids, fats, oils, they are important for daily functioning. You do not want to go on a completely fat-free diet. We have essential fatty acids. So essential is an important term in this lecture. Essential just means you have to eat them. Your body does not make them on its own. If you don't eat them, you will never make them or get them. So essential must be ingested. Linoleic acid is part of the inflammation and fever response. These are found most in vegetable oils and whole grains. So where do we get these lipids from? What are some of our sources? So we've got saturated fats, meats, lard, egg yolks, and we have our unsaturated fats, so nuts, seeds, oils. Our recommended daily intake of these should be less than 35% of your day's calories, with less than 10% of that as saturated fats. So that means you want about 25% unsaturated fats. Unsaturated is kind of what you're leaning towards. Saturated are kind of the ones you want to stay away from. But remember, 10%, less than 10% of these you want as your saturated fats in a daily intake of food. Let me go back there. So that brings up the question, are fried foods bad? Well, it depends. It depends on a lot of things. So, for example, if the oil is not hot enough, then the food is going to soak through with oil, and then you have zero nutrients. You're just eating fried whatever the oil is that you fried it in, that's what you're eating. The vegetable has lost any of its goodness, right? But whatever you're frying. But if the oil is hot enough, the food will seal before the oil has a chance to soak through the food completely. But once food soaks up saturated fat, it's done, right? And then all you're eating there is saturated fat with no other really, good things coming from it. Unsaturated fats, however, those kind of you want to lean towards. Anyways, when it comes to fried foods, just limit your fried food intake because you don't really know what or how they're doing this at restaurants. Lipoproteins. So this is a big one. We're going to talk about this one a lot. Know the difference between HDLs, LDLs, VLDLs, and chylomicrons, okay? Know the difference. These are going to show up on your test. Do not be surprised. These will show up. Know this slide. Make flashcards. All right. So lipoproteins is what your medical tests are measuring. So HDLs, LDLs, VLDLs, not really measuring chylomicrons, but we're going to learn about them anyway. There are two sources here. They are made in your body, and they are dietary. Dietary foods that you're ingesting, they get broken down. They're actually not dangerous. So cholesterol that you eat is broken down just like any other food. The cholesterol that your body makes is the one that clogs your arteries, okay? So remember that difference too, just in your everyday existence. The cholesterol that you're eating breaks down like everything else. The cholesterol that your body is making is the one that can clog your arteries, and we're going to talk about that. So your high density lipoproteins, lipoproteins, HDLs, these are good. Okay, these are what you want. These are made in the liver. It's basically a hollow shell of a little bit of lipid and a protein coating it. It goes around the body, picks up cholesterol. The next time the blood is cycling back to the liver with the lipoprotein in it, it's going to dump off the cholesterol. And that liver is going to take the cholesterol, it's going to make bile out of it, and it's going to get rid of it. So HDL acts like a cholesterol sponge, if you will. Soaks up the cholesterol, takes it to the liver, converts it to bile, and gets rid of it. Which then brings us to LDLs, low density lipoproteins. These are bad. Okay, so these are also made in the liver. They are higher in lipid content than protein content, and they stick to inflamed arteries. Just remember, your arteries must be inflamed first for LDLs to stick to it, right? What can cause this? What can cause inflammation of the arteries? Different things like stress, smoking, etc. All of these, different stressors could cause inflammation. Once your arteries become inflamed, that is when LDL can stick to it and create blockages. Then we get to VLDLs, very low density lipoproteins. So if LDLs are bad, very LDLs are going to be worse, right? So these are also made in the liver. They go to fat cells and they turn fat cells into LDLs. So they take fat and turn it into an LDL, which is bad cholesterol. So you don't want that, because then it's going to stick to your inflamed arteries and create blockages, right? Not awesome. So HDL good, LDL bad, VLDL very bad, okay? And then we have chylomicrons. These guys don't really do too much. No, not really a big deal with these, but just for the sake of learning about them, and so you guys can know that they exist as well. These are made in the small intestine. They go then into the lymphatics, then to the blood, then enzymes and blood vessels break them down. So they are small enough to go through the capillaries, and then they go to fat cells and they don't do too much, like I said. So HDL good, LDL bad, VLDL very bad. Know what they do. Chylomicrons, know what they do. Know the differences. Make a flashcard out of this slide. Effects on cholesterol levels. So yeah, this looks like a whole lot of verbiage, but it's not that bad. This is basically talking about what can we change? What can we do to change effects on cholesterol levels? Saturated fat is mainly palmitic acid. It raises cholesterol by blocking it from being taken back up in the tissues, out of blood, leaving cholesterol in the blood. So saturated fat does not put cholesterol in the blood. It keeps your blood from getting rid of cholesterol it already has. Plus saturated fat breaks down into LDLs, so it's a double whammy with sat fat. Palmitic acid specifically. Unsaturated fats, specifically linoleic acid. So remember, this one is essential, so you must get it from food. Your body is not making linoleic acid. This one lowers cholesterol actually by being broken down into ketone bodies instead of LDLs. And then your kidneys can flush out the ketones, no big deal. Now, I will say this about your kidneys and flushing out ketones, okay? So I just told you that with unsaturated fats, specifically linoleic acid, an essential, it lowers your cholesterol by breaking it down to ketone bodies, and your kidneys can flush those out. However, if you get into, and we will talk about this, too many ketones, you can actually get into kidney failure. Your kidneys can't flush too many ketones out. But in this instance, this is what's happening. All right, so vigorous exercise. How does exercise affect cholesterol? So we go back to the heart in this one. We go back to endocrine system in this one. So vigorous exercise, it causes the right atrium of your heart to secrete less natriuretic peptide. That's going to cause your kidneys to get rid of less sodium and water, which is going to increase your blood volume. So if your blood volume increases and everything else in the blood stays the same, then everything in the blood is now more diluted, right? So that includes the lipoproteins in your blood. So fat cells make more enzymes, take in more triglycerides. Then the VLDLs release some cholesterol, and the HDLs pick them up. And then the liver can eliminate them, and boom, a really long pathway to reducing blood cholesterol levels. So if you did not get that the first time, watch this little section a couple minutes again. Listen to it, write it down. That's how vigorous exercise can reduce your blood cholesterol levels. All right, now we need to know metabolism and lipids also. So lipogenesis, making lipids, or lipids are being created. One of these is called a triglyceride. So you've heard of triglycerides. They are made and stored in fat cells when ATP and glucose levels are high. So you use some glucose and you store some glucose as glycogen, and then more leftover glucose comes here, where you're making lipids, where you're making fats. So with too much sugar and starch ingestion, you are storing them here, making fats, right? Fatty acid synthesis. The specific lipid that you are making is a triglyceride. So unfortunately, the conversion of glucose to fat is a very easy process. But when you do need that energy, you want to break down that fat. We call this lipolysis, right? Lipo fat, lysis breakdown. For this, you need oxaloacetic acid. It's a fatty acid that causes the breakdown of fat. Without it, you're making ketone bodies. Too many ketone bodies, ketogenesis in the liver. Too many ketones are not good for the kidneys. So think about the diet keto. So you're eating fat to break down fat. That's the kind of the idea behind keto. However, if it backfires, then you're making too many ketones for your kidneys and kidney failure can happen, right? So interesting stuff. Remember what oxaloacetic acid does to the kidneys. Okay? Remember that one with lipolysis. Proteins, super important. This will also show up on the quiz, so know this list of uses. This section of nutrition has the longest list of uses. So muscle contraction, motility of cilia, structural components of cell membrane, fibers and collagen, keratin, elastin, globular proteins are found in antibodies, hormones, hemoglobin, enzymes. Plasma proteins transport lipids. They control viscosity. Proteins are also used as pH buffers. Without proteins, none of this would happen, okay? So know what proteins do. So the recommended daily of this, the recommended daily allowance is actually your body weight times 0.27 for how many proteins per day you should be eating, per gram per day. Grams of proteins per day you should be eating. There's not an actual set number because it's going to be different depending on your specific weight. So more proteins recommended for people that are under stress, someone that's injured or someone that has an infection, for pregnant women, for children, for highly active people, for elite athletes, etc., etc. However, too much protein, again, you can end up with kidney failure, ketoacidosis, too many ketones, so everything's got to be at a good balance here and everywhere with everything else. Some dietary sources are eggs, milk, fish, most meats. They're going to contain complete proteins. Incomplete proteins are associated with legumes, nuts, and cereals. However, if you combine these two, the complete proteins and the incomplete proteins, you will get all the essential amino acids that you need. And what does essential mean again? Essential means that you have to eat it. You're not going to get it naturally. Your body's not going to make it naturally anyway. So remember, a string of amino acids is called a polypeptide chain. A polypeptide chain is a protein. So we learned this either in A&P1 and CHO Bios. There are 10 essential amino acids that cannot be made by the body, and there are 10 inessential amino acids, or just 10 amino acids that can be made by the body. So remember, essential cannot be made by the body. You have to eat the essential amino acids to get them, or essentially you'll never have them. It's all or nothing deal when you're making proteins, right? So complete, they have all they need all at once. Incomplete, lack one or more at a time. So it's an incomplete protein, right? Usage, about 70 to 90% of animal proteins are used. About 40 to 70% of plant proteins are used. So that means you'd have to eat like 2 cups of rice and beans to end up at the same usable protein of an 1/8 pound of burger. So for vegetarians, you're going to need to eat at least double to get kind of that same proportion of protein that you should be getting. I'm not saying anything about, being a carnivore or a vegetarian, just that's the breakdown there. That's the balance there. Here's an image, finally a picture, right? I told you this lecture was not going to have that many pictures, unfortunately. But this is a breakdown of all of the amino acids, right? All the essential amino acids. You don't need to memorize these. You don't need to know most of these. But you'll notice some overlap here between corn and beans. So if you're just eating corn, you got up to here, right? Yellow and green. If you're just eating beans, you got the blue and green. But if you're combining the corn and the beans, you got all of the essential amino acids that you need. We're not looking at these 2 purple ones. Those are for infants. We're just looking at the yellow, green, and blue. So that's what that means with complete versus incomplete. Together, we are complete. Alone, we're incomplete. So what are minerals exactly? So minerals are actually elements taken by plants from soil or water, exactly what it sounds like, minerals in the earth. There are 6 required in moderate amounts. So calcium, phosphorus, potassium, sodium, chlorine, and magnesium are required. And there are tons of trace minerals too, but we won't get into those except to just touch on them. So calcium, phosphorus, and magnesium salts, they harden the bone. Iron is essential for oxygen binding to hemoglobin, which we know from our blood lecture and a couple others. Iodine is necessary for thyroid hormone synthesis, and we get that from iodized salts. Other parts of the world get it from seaweed and don't actually need iodized salts. And then we have sodium and chlorine as electrolytes in our blood. Vitamins. Most of these you get from the food that you eat, so they are dietary. Some of them your body makes. Those that your body can convert into vitamins are called provitamins. So niacin is a provitamin. It's a B vitamin from tryptophan amino acid. Vitamin D can be made from cholesterol. Vitamin A from carotene. So these are from yellow, orange veg. So think carrots, carotene, carrot, easy, right? Vitamin K and B vitamins, pantothenic acid, biotin, folic acid. So all 3 of those are B vitamins. And those are synthesized from bacteria in the large intestine. We have 2 types of solubility with vitamins. We have water and fat-soluble vitamins. Water, easily dissolved and quickly excreted. Vitamin C is used for hemoglobin synthesis. It's used in connective tissue. So with connective tissue, if you bruise really easily, it might be because your vitamin C levels are too low. And vitamin C is really important in antioxidants that lower free radicals. So it could reduce the risk of cancer. And then B vitamins are coenzymes and carb breakdown. Fat is mostly stored in the liver, except vitamin K. Vitamin K is actually not stored in the body. Vitamin A is actually visual pigment in the back of the eye. It's not a color. Not the color that you see in somebody's eye. It's in the back of the eye. And vitamin A is also found in epithelial lining health. some fish oil that you take, if you take them, have vitamin A in it. The omega 3s, the fatty acids, they're good for your eyes. Vitamin D in calcium absorption and bone mineralization. So people with osteoporosis, they have low vitamin D. That probably caused their osteoporosis. Vitamin K in blood clotting. Vitamin D Vitamin K is essential in blood clotting. It's also essential in vitamin D transformation. So you got to get vitamin K essentially to activate vitamin D, right? And then vitamins A and vitamins E play an antioxidant, reducing cancer risk. So here's some deficiencies and toxicity. So deficiency is too low, toxicity is too high, right? So if you're vitamin A deficient, some symptoms can be night blindness, dry skin, hair, dry eyes, cloudy corneas, be more prone to UTIs, GI infections, respiratory infections. This is going to be the most common deficiency that we see in ourselves. Now, there's also vitamin A toxicity, so too much. You can have symptoms of anorexia, nausea, headaches, pain, fatigue, fragile bones, hair loss, enlarged liver, spleen, birth defects. So be careful if you take vitamin supplements, basically, is the warning here. Vitamin D deficiency can show up as heart disease, asthma, especially in kids, cancer, muscle weakness, pain, fatigue, depression. And then vitamin D toxicity can actually happen from over tanning. But remember that vitamin D is fat soluble, so this can be stored. So like A, it can reach toxic levels if it's too high in your body. Again, you can get it from over tanning. You can get it from estrogen supplements, from thiazide diuretics. So these diuretics are usually prescribed and combined with blood pressure pills to reduce water. So it brings your blood pressure down. But that can actually make you store more vitamin D as a result. Too much vitamin D can also you can also get it from eating wild game liver, interestingly enough. But symptoms are super general for vitamin D toxicity, right? So fatigue, nausea, etc., etc. But some of the more unusual ones to look for are general tinnitus, so ringing in the ears, unexplainable constipation, or hypertension for no reason. How do we use fuel? So this is the order. This is basically a summary. It ties together all of these lecture slides. So glucose is first, right? Glucose levels are high. We're using glucose first. Leftover glucose gets put into glycogen. Glycogen stores are full. Then any extra glucose gets stored as fat. If glucose levels are low, then glycogen is broken down. If both are low, then we break down fat. You need some byproducts of carbs to break down fats correctly. Carb-free diet, think Atkins. It causes fat to break down to ketones, which can be dangerous for your kidneys, right? Too many ketones in your kidneys can cause kidney failure. And then when fat's low, you break down protein as a last-ditch effort for survival. So if you've ever seen somebody that's bulimic or anorexic, their muscles have been used to fuel the body so that they can live, and they are digesting their muscles, actually. People in starvation mode. These are people in starvation mode, but think people that, are in different areas where they are starving, and they are, they look like skin and bones. That is because their bodies are digesting the muscle and not anything else that we've talked about. So we're going to move on to basal metabolic rate. Metabolic rate is measured, it can be measured anyway, in a calorie meter with heat transfer. Basically, you get into a tank, and a lab associate measures how much you increase the temperature in that vessel. Very inconvenient, but you can also measure it with a spirometer and measure how much oxygen was used. A lot depends on your physical activity, mental state, and thyroid hormone. So if you're hypothyroid, you're going to have lower metabolic rate. If you're hyperthyroid, you're going to lose weight faster. You're going to have a higher basal metabolic rate. Basal metabolic rate, it declines with age, and it actually declines with rapid weight loss. So your metabolism actually drops if you are losing weight too quickly. So your body thinks that you are in starvation mode when you lose weight really, really fast. That when you start eating normally again, your body's going to hold on to everything that you give it. So to have a high metabolic rate, it actually takes a lot of work with exercise and diet to keep that BMR up. So you're not sabotaging yourself, right? You're not, taking diet pills or whatever that's inhibiting your hunger hormone, your ghrelin, and then you stop it, and then your ghrelin is back to normal, and then now you're hungry and your appetite is high, and now you're regaining everything, and you're yo-yoing, right? That's why you're yo-yoing. That's why you're with that really, really rapid weight loss, and you going back to a normal eating pattern. Your BMR has actually decreased, and now your metabolism is very, very low, and it's holding on to everything that you're giving it. So you're not going to be losing it. You're going to be regaining everything that you just lost. Obesity. So BMI, body mass index, this is a good indicator of how much body fat you have, unless you're an elite athlete. So if you're a power lifter, somebody that's very, very muscular, BMI is not going to work for you, because this is using weight only, and muscles weigh more than fat. So someone that is super, super muscular, they would end up showing obese if we use this as our indicator of body mass. So that's my disclaimer. How you measure this is you take the weight in pounds, you multiply it by 705 divided by the weight in inches squared. Divided by the height. I can't read. So weight in pounds multiplied by 705 divided by the height in inches squared. If your BMI is 25 to 30, you're kind of in the overweight section. 30 plus, obese. With obesity, we see a higher incidence of atherosclerosis, diabetes, hypertension, heart disease, osteoarthritis. Osteoarthritis, think about, joints carrying extra weight. It's going to put some strain on that. So we could control these issues by doing the following. So to lower our LDLs, so our bad fats, instead of eating saturated fats, switch to something with omega-3s, omega-6s. That's also going to be good for eye health. Fish oil. Fish oil supplements is usually what people take for their omega-3s. Increase your soluble fiber intake, stop smoking, reduce your caffeine, decrease your stress levels. Usually if you drink less caffeine, your stress will lower. I'm not saying get rid of the coffee, but maybe some of the soft drinks that you're drinking. To lower triglycerides, replace high glycemic index foods with some lower glycemic index foods, so foods that burn slower. High glycemic index burn really, really fast. Low burn slower, which is going to be a little bit better for you. You're not going to burn through them as fast. To increase your HDL, so your good fats, right? Your good cholesterol. Lower your carb intake overall to less than 25% of your calories. So anything with sugar, flour. So think white out, okay? White out. Use the brown rice. Use the whole grain breads. Less than 25% of that. If you don't want to switch to there, think 2 bite carbohydrates. So 2 Hershey's Kisses, half a slice of bread. I know it sounds ridiculous, but it is what it is. Sometimes we have to make sacrifices, right? To decrease your body weight or your body mass index, you can reduce your calorie intake by 3,500 a week to lose 1 pound a week. Do not reduce your calorie intake more than 1,200 calories a day. because then your body goes into starvation mode. So you need at least 1,200 calories a day so your body isn't in starvation mode. And then I've included this little list, sorry, of things that you should probably limit in terms of your daily diet, just for fun, you know. So look at some of these saturated fats. You got bacon, sausage, butter, lard, lunch meat, organ meat, so, you know, things like livers, gizzards. Monounsaturated fats, again, not great. You want to go polyunsaturated, right? So these are, I'm so sorry, let me get a drink. These are almonds, avocados. Unfortunately, both are amazing. Canola oil, cashews, olive oils. And then your high glycemic index. Really, your high glycemic index and your saturated fats are the ones that you mostly want to stay away from. Monounsaturated really limit. But your high glycemic index, bagels, cornmeal, pineapples, rice cakes, potatoes, pizza crust, pretzels, believe it or not, watermelon, table sugar makes sense. You know, that, I think everybody knows that one. But there are some really, really high glycemic index fruits too that, you know, if you're having, you know, problems, or you want to, you know, lower your body mass index or your weight or whatever, these are some that if you stayed away from, you switch to, you know, something different. So instead of white bread, switch to whole grain bread. That would benefit you. And that's all I got. That's it for our nutrition and metabolism chapter.